In the high-stakes environment of urban real estate, pricing a property feels like an exact science. To understand how economists map this market, we can look at a premium benchmark, Property 45. At 3,232 square feet, Tier 1 Property 45 prices at 2.08 crore, setting our baseline. Property 11 drops to 2,840 square feet, so logic dictates a proportional drop to an estimated 1.8 crore, but it actually sold for 2.06 crore, a 25 lakh discrepancy. A miss that large often leads people to assume the algorithm is broken or that predictive models are merely unreliable black boxes. This 25 lakh gap represents the exact starting point for a deeper investigation into how we actually measure the world. Before any analysis happens, raw data is essentially noise, a pile of scattered building blocks. This is the visual representation of our Indian urban real estate dataset. We have 60 individual properties floating in a vacuum, with no discernible link between their features and their final price tags. To find the underlying structure, we apply the logic of dependence. We assume that the outcome, the price, awaits instructions from an input, like the square footage of the house. The moment we plot those two variables against each other, the chaos reorganizes. A clear upward trend emerges, allowing us to draw a regression line, a baseline rule, straight through the center of the mass. Economists use regression to deliberately sort through variables, isolating the dominant rules that govern a market. But the rule rarely dictates every outcome. Look at the anomalies, the points that ignore our regression line entirely. This is the mathematical inevitability that a single trend line will rarely touch every point of reality. Take Property 16. It's over 2,700 square feet, yet its price falls well below our trend line. The square footage implies value, but sitting nearly 21 kilometers away from the nearest IT park drags the actual price down. Conversely, there's Property 24. This 784 square foot home punches far above its weight class because it sits a mere 400 meters from a metro station. That convenience premium inflates the cost. We handle this by adding these secondary inputs to our equation. By feeding commute times and property age into the model, we can bend the math to account for these specific discrepancies. Yet, even after calculating every single measurable column in our dataset, a gap between our prediction and the final sale price remains. That gap exists because markets are driven by people. You cannot build a spreadsheet column to penalize a bad paint job, subjective neighborhood aesthetics, or notoriously grumpy neighbors. We group all of that unquantifiable reality into one mathematical placeholder, the error term, denoted by the letter U. This leftover gap accounts for the world's inherent complexity, serving as a reminder that even the best models have limits. Now, let's return to the 25 lakh discrepancy on Property 11 and view it with a new understanding of the math. This chart breaks down the exact composition of the gap. Our expanded model shows a large portion is justified by proximity to the metro. Another chunk is explained by the building's age. The glowing section at the top is the remaining mystery, our error term. By mathematically isolating the measurable facts from the unmeasurable ones, the model fulfilled its core purpose. The job of a data scientist involves constantly refining these tools until only genuine human mysteries remain unmeasured. Econometrics allows us to acknowledge the chaos of the real world while maintaining the humility to know exactly where the math stops and humanity begins.